Good morning, good afternoon, and good evening. Thank you everyone who is attending today's webinar, Navigating Sustainable Futures, Engineering Meets Sustainability. This webinar has been organized thanks to the IMarEST and the MLA College. And in case you are watching this webinar on live, you can post any question in the Slido application. My name is Rodrigo Pérez Fernández, and I will be your host for what promises to be a rich and thought-provoking conversation and the intersection of two dynamic disciplines, engineering management and sustainability studies, with a specific focus on the maritime sector. However, as the speaker will demonstrate in this seminar, embedding sustainability and its principles within the engineering sector goes beyond that just the maritime industry. Navigating Sustainable Futures, Engineering Meets Sustainability will be a dynamic conversation at the crossroads of engineering management and sustainability studies with a spotlight on the maritime sector. As our speakers will show, sustainability in engineering extends far beyond ships and ports. It's a challenge that touches every aspect of infrastructure, innovation, and identity. We find ourselves at a pivotal moment. Climate change, energy transitions, global logistics, and coastal development are reshaping these spaces at unprecedented speed. Maritime environments, our coast, ports, shipping networks, and ocean-facing communities are under growing pressure. And yet, these challenges are not just technical. They are deeply social, cultural, and ecological. They touch not only on infrastructure and innovation, but also on identity, heritage, and justice. That's why today's dialogue matters. On one side, we have the tools of engineering systems thinking, life cycle modeling, strategic trade-off, and high-impact leadership. And on the other side, we have sustainability grounded in human geography, a field that explores how people relate to place, how landscapes are lived in and shaped, and how society and nature co-create meaning. Today, we'll be exploring questions such as how do we redesign ports, fleets, and coastal infrastructure in ways that are both low carbon and locally grounded? What does it mean to lead engineering teams that prioritize resilience, inclusion, and cultural continuity? And how do we reframe innovation, not just a problem solving, but as co-creating features with the communities who live in or by and with the sea? We are incredibly fortunate to be joined by two outstanding experts today, each bringing deep experience and a unique insight to this cross-disciplinary conversation. I am pleased to introduce you Dr. Marie Herl, Senior Fellow of the Higher Education Academy. She is an academic and tutor at the MLA College since 2024, working within the Global Sustainable Development Portfolio, a program designed to support professionals in developing meaningful applied sustainability knowledge through undergraduate and postgraduate study. Mary brings not only academic excellence, but a commitment to transformative teaching. As a human geographer, her research explores how people connect with place, with the location, particularly in protected areas, and how social and ecological landscape evolve together. Marie's teaching investigates how nature, society, and place are reshaped by global processes. In her latest work, especially through the MLA's partnership with CIFAL City of London and the United Nations UNITAR Network, Marie is delving deeper into the role of sustainable development goals in building resilient, inclusive, and sustainable societies and communities. Our second speaker is Dr. Paul Folland, joined MLA in 2022 as a senior academician, bringing decades of experience and the intersection of engineering, management, and education. With a distinguished academic background from the National University of Ireland, Galway, where he completed his PhD and Master's in Engineering, Paul has contributed to numerous European Union framework projects focused on performance management, supply chain, and product lifecycle strategies. His teaching and leadership roles at the University of Exeter and the University of Chester have spanned subjects from engineering design and manufacturing systems to lean operations and research methodology. He has mentored countless students through innovative project work, always encouraging creative thinking and rigorous inquiry, something that he continues with a great enthusiasm at MLA College. So with these two thought leaders at the helm, we'll explore both the macro systems and the human stories that define sustainable maritime futures. So without further ado, let's dive in. I will moderate in a series of themed questions, and towards the end, we'll open the floor for your own thoughts, reflections, or questions. So let's set the sail. So I'm going to start with Marie. So let me start with the first question. Marie, from your perspective as a social scientist, how should we define sustainability in engineering context?
Thank you, and good morning, everyone. And thank you, Rodrigo, for this question. So I think we need to kick off things with a bigger picture view. So from a social science perspective, sustainability in engineering is about designing, building, and operating systems that can really strike a balance between protecting our environment, supporting economic growth, and promoting social equity to make sure that today's needs don't put at risk future generation needs. So I guess building on from your question, why is sustainability more important than ever for engineers? Well, I think the answer is both practical and ethical. Engineers shape the world around us. I mean, you think about the buildings, infrastructure, energy systems, and so many more examples. And as we face increasing challenges like climate change, biodiversity loss, pollution, I think engineers are really uniquely positioned to find solutions, not only to reduce the harm, but also to actively restore the balance to help and build more resilient and sustainable communities. I think it's important when we think of a definition of sustainability to remember that regulations are evolving very fast. So governments and industries are tightening the rules on carbon emissions, energy efficiency, waste and water use. So in some ways, engineers must now weave sustainability into their designs from the very start. And also, the IMO is really at the forefront of this by developing mandatory regulation to protect the marine environment from the potential impacts of shipping activities. So on that note, let's zoom a little bit more on the maritime sector, because I think in there, sustainability goes far beyond just emissions and efficiency, understanding the relationship with the ocean and marine resources. So from fishing communities to port workers, marine engineers are, I think, really well placed to understand how people live, their livelihoods, their cultural identities, and how all of this is deeply tied to the sea and to the ocean. So sustainability in this context, if we look at the definition, it's not just about ticking regulatory boxes. It is about ocean literacy. And that's a concept on which I will come back quite a lot in this webinar. So ocean literacy is an integral part of the ambition set by the United Nations in the context of the UN Decade of Ocean Sciences for Sustainable Development, which aims to reverse the decline of our ocean systems. And we are right in the middle of it because it started in 2021 and should finish in 2030. So to keep it simple, ocean literacy is the understanding of the ocean's influence on humans, so us, and our influence on the ocean. And I think a lot of people are not aware of the fact that the ocean is linked to global issues like obviously climate change, but also food security, human health, and the global economy. So we find that ocean literacy is increasingly embedded in maritime policies. Just to give you an example, we can think of the European Union's Blue Growth Strategy, which focuses on sustainable growth in the maritime sector. So that's kind of a definition or some elements of the definition of sustainability. But what does it look like in practice for marine engineers? I think when you look around, there are really great examples of successful projects which with sustainability within the maritime industry. And here we can think of designing ships for greater fuel efficiency, choosing recyclable or biodegradable materials in shipbuilding and maintenance, developing advanced treatment systems for wastewater and ballast water to prevent marine pollution and protect biodiversity, which is so important, but also innovating in ship recycling to ensure safe and environmentally sound dismantling of the ships. So to answer your question in a nutshell, I think a definition of sustainability within the engineering or maritime industry should consider probably embedding a bit more of a holistic approach, which combines technological innovation, environmental stewardship, and social responsibility at every stage of the project. Because ultimately, sustainability is not just a technical challenge, it's very much a mindset shift. Thank you for your question.
Thank you, Marie. Very nice comments. And I am sure that there are many people in the audience sharing the same thoughts. So we are going to move quickly to our second speaker, Paul. From an engineering management perspective, what's the biggest challenge in embedding sustainability? And related with that, what about more specifically within maritime projects?
First of all, Rodrigo, thank you for having me on to on the webinar to look at this topic, which is one of those areas which is growing all the time. We are increasingly adding new segments or new concepts to this discussion with sustainability, and it's good to have a subject matter expert specifically looking at sustainability in Mary on the call, because she often has a huge overview of lots of different areas that engineers typically don't know too much about or typically remain underexplored in your typical engineering curriculum. So it's always good to have a speaker outside of engineering reflecting in as well. So it's good to have Mary's perspective. I think following on from what Mary said, I think one of the major challenges that we have in the engineering discipline, and it's tackled in engineering management, is moving the discussion beyond simply looking at environmental activities. Often I find, and maybe you disagree, Rodrigo, that a lot of the discussion comes about around sustainability within engineering. It talks about environmental issues all the time. There's typically less around things such as social equity, which Mary talked about a little bit there. There's a little bit, I suppose, around economic viability when we're talking about kind of cost-benefit analysis for the organizations that we work for and the engineering solutions that we kind of propose and whether they work for the company. So there's a little bit of that, but things such as the kind of social equity side of things, I think they tend to fall back a little bit or they're underexplored. That's what I find typically. Now, of course, you could probably point to examples where they are brought forward. We have things such as stakeholder analysis, and we try and bring in local communities to talk about these things. But I do tend to find that a lot of the work that we do as engineers, often this tends to get forgotten a little bit. There's a risk, obviously, with this kind of approach towards solving engineering problems. It's a bit reductionist, and we could end up with kind of very good, shall we say, environmental solutions, but that aren't necessarily tied into kind of social perspectives or even economic perspectives. So there's a danger of kind of being a little bit suboptimal. Now, having said that, I understand why it's that way as well. If you look at the kind of landscape that we're in the middle of the 2020s, and the landscape that's out there, the regulatory landscape that we're facing, environmental issues are pushed to the fore, particularly across kind of the maritime environment. We're all familiar with the sorts of things that are out there. The IMO's greenhouse gas strategy from 2023 is really putting clear goals on everyone's radar around net zero emissions by 2050, and there's going to be checkpoints for 2030 and 2040, and we're all going to be measured in some way against these checkpoints. We're not too sure how we're going to be measured, but we're going to be measured against these sorts of checkpoints. It's obvious that we're going to have this kind of environmental purview. So it's quite understandable that engineers look at probably the kind of environmental angle first and foremost. So for engineering managers, this kind of creates this kind of front-loaded need to kind of consider sustainability planning. And by the word sustainability, I mean, probably more environmental kind of planning than anything else at this stage, you know. Looking at some of the things that Mary talked about there, technologies, alternative fuels, vessel design, and how that can change to kind of improve some of these overarching goals that we have for sustainability. We don't want a situation where, I don't know, maritime companies are facing refits every so many years, which are costly, or facing kind of regulatory penalties as they go on. So we have to kind of, I suppose, look for the sweet spot where we're offering engineering solutions that are flexible or adaptable over a period of time. Because as we know, the regulatory environment that we're faced with tends to change, and it seems to change, seems to go quicker and quicker. There's changes within this kind of sustainability environment that we see. One of the key things I think we're going to see more and more, and it's going to be more and more of a challenge maybe for working engineers and engineering managers out there in industry, is this need for environmental, social, and governance reporting, this ESG reporting landscape that's quickly emerging. We didn't really talk about this, I don't know, 10, 15 years ago that much, but there's a whole range of regulatory instruments that are starting to emerge that we're starting to see. Now, it depends where you are in the world, and there's going to be different regulations. Different countries produce different regulations, but like we're here in the UK, and there's a whole range of things that are tied into the reporting outcomes that companies are expected to do. Things such as the climate-related financial disclosures, sustainability reporting, streamlined energy carbon reporting. Even the Companies Act itself has been changed, the Basic Act, to allow for more kind of citing of environmental and social factors within the reports that come back from companies. We're seeing far more information expected to come out of companies with regards to all these aspects of sustainability. And I think some of the things, the educational background that some of us have, we mightn't be set up to do this, or we might be uncomfortable with this kind of increased focus on this. So for some of us, at least, I think it's kind of nearly back to school on some of these things and trying to learn kind of new skills. And so there's definitely challenges there for us as we go forward.
Yeah. So thank you very much, Paul. I think that you're spot on. I agree on your comments. We are always students, even the teachers. So we will continue facing challenges and try to solve them. So I would like to move on the challenges. So Marie, in your experience, considering the contemporary challenges we are facing, what can marine engineers do to make a difference when it comes to sustainability?
That's a really good question, and I agree. I agree with Paul. I think if we start with a big idea, engineering has really the potential to be one of the most powerful tools to create a sustainable future. But it can also go the other way. If we're not careful, it can lead to some environmental problems. So I think that's why engineers, and especially marine engineers, have a unique opportunity to make a real difference nowadays. And while I was preparing the webinar, kind of doing a bit of research around, I was happily surprised to find that the IMO is organizing in 2025 a World Maritime Day theme, which is entitled Our Ocean, Our Obligation, Our Opportunity, which I think completely relates to the concept of ocean literacy I was talking about earlier, and all the key subjects that marine engineers and engineers in general should consider when it comes to looking at ocean resources. I also very much agree with Paul. I think, Paul, you mentioned about the socio aspect, but also the economical aspect. And we find there's always a conflict when it comes to sustainability between doing what's sustainable and keeping the costs down. Sometimes, unfortunately, the greener option costs more upfront, even if it saves money and the environment in the long run. So I think that's why it's important that decisions need to happen in engine room, but also need to happen at the top where the bigger strategies are being set up. What I find really encouraging, and this was prompted by a conversation I had with my colleague, Dr. Tamsin Dobson, who is a marine engineer, is that there is a new wave of marine engineers coming through, and they are really passionate about sustainability. Today's graduates have learned about green engineering from day one, and they expect to see it in action when they join. So sometimes from my conversation with Tanzin, I understood that they were a bit surprised when it's not already in place. So if we can build on the energy from these younger engineers and combine it with the experience and the energy of those who've been in the industry for years, I think that will be a really great position to face the challenges you were mentioning, Rodrigo, to drive real sustainable change. And that's applicable across sector. So what are the important aspects to consider when you want to make a difference? Well, first, as Paul mentioned, design decisions matter. So every choice an engineer makes, from the materials used to the way your ship is powered, has long-term impact on the environment. And in that regard, for example, the Czech project in Europe is a really interesting project because it brought together experts to rethink ship design from the ground up. So they created cargo ships with giant sails and cruise ships powered by hydrogen, showing that it's possible to dramatically cut emissions with smart integrated design. That was a project on which my colleague Tamsin was part of, and she told me all about it. And that's a really great example of how to tackle those challenges. And also, tackling these challenges means that change is not just technical, it's also very much ethical. So engineers are also able to make choices that will affect people and the planet. So that comes with big questions like, should a ship be easy to recycle? Should the port serve local communities better? And these are the questions of values as much as technology. And let's not forget the human side of sustainability, as Paul mentioned earlier. The ocean is not just a resource, it's a place which is full of history, culture, and meaning. And I think if we ignore that, we risk losing indigenous practices, traditional fishing rights, historic shipbuilding knowledge. So sustainability means protecting both the environment, but also the stories that connect people to the sea. So I just wanted to take a real world example here to kind of finish on this question. In Scotland, local fishers are working together with the government and marine engineers to actually co-manage marine resources. And in doing so, marine engineers are helping by developing high-tech monitoring systems to track fish stocks and activity, creating better ways for communities and scientists and regulators to communicate. And they also help in designing greener boats and ports to support the local livelihoods and protect the environment. So to summarize, I really think that marine engineers are at the heart of building a more sustainable and inclusive future for our oceans, and they can be part of the solutions to face those big challenges.
Yeah, thank you, Marie. I think that you raised very good points. So I would like to enter more in deep on the landscape shifting and how engineers design with adaptability in mind, especially when this landscape literal and socially shifting. Paul, how the engineers can design with this adaptability in mind?
Yeah, it's the big question, isn't it, Rodrigo? I mean, as engineers, we have to be so aware now of the kind of the broader context in which we offer engineering solutions. We have more and more constraints now. A lot of them are external constraints. Kind of, we talked about the regulation. We talk a little bit about society and kind of the ethical things that are shaping the engineering design decisions that we have to use to kind of come up with these acceptable outcomes, if I can put it like that. So in many ways, I suppose the kind of the burden on us as engineers has tended to grow. Traditionally, engineers had to kind of suit the dictates of their company and work pretty much on kind of solutions that worked for their company. Now there's an awful lot of additional requirements being placed on engineers to fit in all of these other constraints that they wouldn't typically have had in shall we say, traditionally in the old days. So there's a significant increase in kind of burden in that respect. But I think you mentioned the word adaptability there, and that's the key here. The adaptable engineering is going to be extremely important, and the concept of being adaptable in any way that we can. we have to recognize as engineers that the landscape around which we're providing solutions is changing, and it will probably continue to change with rising sea levels, climate patterns becoming more unpredictable, human behavior, kind of migration patterns, and energy consumption, and topics of environmental awareness, which only ever seem to increase. There's increasing awareness among the public and various stakeholders out there. These are constantly evolving, and being an engineer asked to provide a solution for a particular problem, you have to be aware of this kind of surrounding, which can be uncomfortable, let's be frank, for engineers, especially coming out with a very technical tool set and suddenly being thrown into these kind of new, very nuanced conversations sometimes that are emerging. It can be difficult. But yeah, adaptability is going to be key. It implies that any engineering solutions that we offer are typically not a one-size-fits-all proposition. They're going to have to be adaptable to various scenarios that are thrown up by different circumstances or evolving circumstances. So this could be any kind of aspect of kind of the sustainability model that we've been talking about, whether that's kind of the social equity side or the environmental aspect, which we're probably more familiar with, but also kind of economics as well. But maybe it's a combination of all these as well. So one of the key strategies, I suppose, would be things such as modular design, trying to create an infrastructure or designing in components or units that can be added or removed or refitted or retrospectively changed as necessary with evolving circumstances, so that engineers can try to ensure that the systems that they produce and offer to the public remain relevant over time. For example, in kind of port design, to take a maritime context, looking at things like seawalls and the way that these have been designed to be kind of in stages or with floating docks that raise with the water levels. This kind of flexibility helps to try to avoid obsolescence and exposure of the full system to complete overhauls. We have a particular challenge at the moment with kind of green fuels in maritime engineering. I see lots of students come to me with dissertations that talk about green fuels and selecting different green fuels, whether it's ammonia or LNG or hydrogen, or there's a whole range of them. One of the key questions I always ask students is, what's the retrofit cost and the reinstallation cost, and what happens if the goalposts move? We see a lot of the goalposts moving all the time in this scenario. Have we done a reinstallation cost, and then we find we're going to have to do another retrofit cost later on, and the costs begin to build up all the time? So can we be flexible in what we offer here? Can we look at things like fuel flexible systems that can handle multiple different types of fuels? For example, is that a possibility rather than creating an optimal solution for just one type of fuel? That's just a simple example, but it's the one that comes to mind kind of when I consider maritime projects that I've seen. Overall, as I say, the engineers have to remain acutely aware of the broader context in which they're designing solutions. The imposition of external constraints, whether they're regulation or societal expectations or ethical expectations, they're going to continue to shape the perception of what's an acceptable outcome or what's an acceptable solution put forward by engineers. So I suppose that's one of the key messages I'd push out for anyone looking at designing engineering solutions today and managing those design process is this need to continue to understand the external environment and how that impacts upon the design decisions that we take.
Thank you, Paul. Very nice reply. I think that it cannot be done better than you have done. So, Marie, reading your bio, you are an expert in the United Nations Sustainable Development Goals. And you know that these SDG goals are reshaping global priorities. So how can sustainability professionals and engineers influence these systems?
Well, they can do it in many different ways. And I really like what Paul just said about adaptability, because this is very much at the heart of the UN SDGs. And I would add to that as well the concept of resilience, which is very much needed in our times to face those challenges and to implement the UN SDGs. So I think the UN SDGs can be really useful for engineers, may they be in the maritime sector or other sectors, because they give us a useful shared roadmap. So why should they care about the SDGs? Well, I think they are not just abstract targets. They are really a practical guide that can help the industry to be safer, cleaner, and more resilient, as I just mentioned. And I think marine engineers specifically can play here really key role in advancing those SDGs through their technical decisions, project management, and industry leadership. So in practice, again, what it would look like, Paul and I spoke earlier about designing a more sustainable maritime infrastructure. So I'd like to focus on one SDG here. There are 17 of them, but I'm just going to focus on SDG 14, which is about life below water, which should really be at the top of the awareness agenda. And when you look at the IMO program, it is very much embedded into what they are doing. So marine engineers are central to SDG 14, Life Below Water, which is about protecting marine and coastal ecosystems, reducing pollutions, and tackling issues like ocean acidification. And they are central to that because they can really have an impact. They can use advanced monitoring technologies like drones, remote sensing, 3D imaging to, but also map and manage marine habitats. They can support policymakers and communities to make better decisions. So marine engineers can really advance the SDGs by embedding sustainability into the different stages of maritime design, operation, and training. So I guess the challenge comes down to how do you bring the SDGs to life in some ways? How do you make them more visible and raise that awareness for everyone who's working on a ship? Well, I think here we could implement some concrete ideas. First of all, it would be interesting to make it more visual, posting SDG posters in common areas, for example, using digital displays or short videos in cruise messes to highlight what each goal means for seafarers and the oceans. That would be a good way to enhance the awareness of people who are working on the ship to understand a bit more what the SDG mean. It can also be about starting with storytelling, so sharing real-world examples of how sustainable practices have improved safety, reduced cost, or protect marine life. So that can also be done on a ship by just sharing other projects that are happening across the world and building on those SDGs. It can also be about connecting actions to outcome, so showing to marine engineers how small changes can have an impact, like proper waste disposal, energy efficient operations, or reporting oil spills, how that directly supports the SDGs and especially SDG 14. Finally, I think it would be interesting to go further within implementing the SDGs by integrating it, being French on that one, integrating it into safety and training. So we could think about bringing the SDGs a bit better during ongoing training, tie them to familiar MARPOL regulations or company sustainability targets. So I think the SDGs for every engineer, officer, and crew member can become almost a support for them to be ambassadors at sea of the SDGs. So by making sustainability part of everyday shipboard life, you're not just meeting the regulation, you're also helping to secure a better future for the oceans and raising that environmental awareness. So actually, if that's okay, Rodrigo, I'd like to ask Paul a little question on that. So I'd like to ask from a very, from a concrete engineer perspective, do you think, Paul, that the SDGs are useful? And is that something you mentioned in your program? And which SDG are you more tied to?
I knew you were going to ask me which ones.
Well,
I always get
really
them mixed up. There's 17 of them, and I always get which ones are mixed up. Yeah, of course.
Okay.
Of course, they're useful. I tend to find sometimes I like the SDGs. Some people tend to use them as a framework, and I find that a little bit difficult because there's so many of them and they go off in such different directions. I think the poor old engineer in the middle can't possibly get them all into every project. So they have to pick and choose, obviously, which ones are most key. In the PG dip in engineering management, we do cover a number of the SCGs. For example, in the first module, we have sustainable production systems, which looks at SDG 9 and 12. What are they now? They're can't remember them. Is it the industry, innovation, and infrastructure one? And something
And
is it the
12 is,
responsibility, production, and consumption one? Yeah. So
that's
we're
right.
particularly we well, thank you. I remember them. So we look at those ones in particular. We also look at SDG 4 and 8, if I remember correctly, in our training materials as well. But we also cast a glance around at some of the other ones as well. And different types of engineers, of course, will be working in different sectors, and different SDGs will probably have speak more to different groups than other ones. Obviously, we're talking maritime here, so as you mentioned, the SDG 14 is going to be kind of one of those key ones as well for kind of the maritime sector, you know. But yeah, we do bring to answer your question, we do bring them in, and we do look at their impact. We look at things such as green manufacturing, how that is typically organized. I do a lot of work on the European Union as a case study. I focus on the European Union because they produce a lot of world-leading kind of sustainability legislation and directives on this area, which tends to act as something that people that are outside the EU tend to have to kind of follow if they're doing business with the EU. They have to follow it. So it does have this kind of global impact across. And they are producing, I don't know, are you where they've produced this circular economy action plan. And there's a whole range of new directives, if people don't know these yet, that are out there, which are some of them are really, really amazing what they're trying to do. Whether they'll do it or not now is another question, but we'll see things like the right to repair, where consumers can come back and ask for to promote product longevity. They go back to the original producers of the products and ask them to kind of repair them or make spare parts more accessible and available. There's also their big focus on this greenwashing concept, which we haven't really talked about today, but the claims that different companies make about their products and whether how green they are environmentally friendly. There's green claims directives, and there's this issue of eco design. So trying
Yeah.
to create these sustainability standards. So there's a whole range of stuff that we go into kind of within the kind of in the PG dip itself. And yeah, it's an active concern for us, the SDGs, but we weave them in. We come in and out. They come in and out of the conversation as necessary. There's no particular one that we try and nail down exactly.
That's
Yeah.
fair enough. I mean, they are all interconnected. So yeah, it kind of makes sense that they are kind of weaved within the program. So yes, thank you, Paul. Rodrigo, back to you.
Yeah. No, thank you. I think that it has been fantastic. So there are many questions and many topics to talk, and the time is flying. So I like the way that you interact each other. So I think that is I love it. So I'm going to start asking you questions. So please feel free to reply any of you. So related with this policy constraint, we know that engineers are often skeptical on policy constraints associated with sustainable practices. So one of the questions may be, how do we lead teams to adopt process thinking without adding red tape? And also, how can we train the next generation of maritime professionals to think both like system thinkers and technical managers? Paul, can you start?
Okay. Yeah, I think it's key in this space that we respect who engineers are and the skills that they have. And sometimes there's a danger that as I said at the start, we're sending them back to school again to start again from scratch. These are deeply technical and educated professionals that are out there working in this space. And I think it's important that we focus on things such as the clarity of the outcomes that we want to achieve, but allowing the engineers the space to achieve those outcomes in the way that's most appropriate. Because every engineering situation that we look at is going to be unique, or it's going to have its unique kind of framing that needs to be taken into context. So, this is like tight on outcomes, but kind of loose on the methodology that you use to kind of achieve those outcomes is going to be important. And it's exactly the same with the sorts of things that we're seeing here coming in from, say, regulations out there. Take, for example, greenhouse gas emissions regs that are coming out. Engineers could be kind of skeptical of these if they don't see how they exactly tie into the kind of engineering project in front of them, or if they feel that they're kind of being imposed from the outside by people that don't really know what they're faced with. So there's obviously skepticism there, but we do have to respect that these are in place, and we have to use these as kind of part of the kind of design targets, the outcomes that we're expecting. So starting off by kind of acknowledging that these goals are there, whether these are kind of the maximum permissible levels of greenhouse gas emissions or for particular gases, and any certifications or compliance targets that we need to kind of hit. We'll set those as goals, but then we free up the engineering team, to work towards their goals as best as they in the best way that they see fit. So they'll develop their own decision support tools. They'll figure out maybe the best way to kind of examine materials or emissions based on sustainability, cost, whatever it is, the life cycle footprint, the existing toolkits they have. So I suppose what I'm essentially saying is we have to kind of focus on the outcomes that are expected, but leave the engineers to do the technical bit, but allow them to take on board all of the kind of additional information that's coming in about these kind of sustainable practices, and allow them to kind of develop these solutions as they need to develop them. Sorry, that's a bit waffly, but that's probably the best I can see for where we're going to go with this kind of space.
Yeah. Mary, how we can train the next generation of maritime professionals?
Apologies, I was on mute trying to bring you back. Okay, so how to train the next generation of marine professional? I think it has to come down to holistic problem solving. So in that regard, I think Paul mentioned about system thinking. And I think that as a framework really encourages maritime professionals to look beyond isolated technical issues and consider the broader impacts of their decisions on the environment, the society, and the economy. So the 3 pillars of sustainability. So for instance, instead of just focusing on making a ship more fuel efficient, a system thinker would also consider how changes affect marine ecosystems, port operations, regulatory compliance, leading to solutions that are better for both the business but also the planet. And I also think that it's very much about embedding sustainability in education. And in that regard, Paul is doing a fantastic job within the PG Deep engineering. And my other colleagues are doing a very progressive work within the BSc and MSc Sustainable Maritime Operations. And they are really trying to embed sustainability within these programs. And that ensures that future professionals understand the importance of environmental stewardship, resource efficiency, and social responsibility from the start.
Perfect, fantastic. So I think that as the time is running very quickly, I would like to ask you a few questions from the audience. There are many, so I'm going to start with one of them. Is there an international recognized framework with technical guidance for developing effective disposal strategies for marine vessels, notably for smaller vessels, and beyond that set out in the aspirations in the Hong Kong Convention?
Yeah, surprisingly, I had a question very similar to this on one of my assessments recently. So a lot of the students have filled me in on this, my current students. There's no particular guidance on this topic currently, alas. I mean, a lot of vessels tend to end up in places such as Bangladesh and India, which have massive shipbreaking yards, some of the biggest in the world. But a lot of the places where we want to recycle or remanufacture the materials tends to be in places such as Europe. So we have a big logistics problem about getting the end-of-life vessels to places such as the shipbreaking yards in Southeast Asia, but getting the parts back to places where they might be recycled or remanufactured. So there's a whole debate around the logistics surrounding this. Then we have the nationality debate, or the national states debate, because we're going across different countries and they'll have different regulations about what they'll accept and what they won't accept. In short, the answer, Rodrigo, unfortunately, is that it's one of those that needs the regulators to kind of sit around the table and do a lot of more work, probably with the IMO kind of leading the discussion.
Perfect. And I would like to ask you one question that probably is going to be something that everyone is asking is, what's one transformative idea or innovation you believe could refine the maritime sustainability in the next 10 years?
I'll go with that
You
one.
can start, Paul.
Yeah. My background in industrial and manufacturing engineer leads me to look at this concept of digital twins. I'm not too sure if you're, Rodrigo, if you're familiar with the kind of the digital twin concept and how it's being used. It's typically been used in the maritime sector in kind of ship design and kind of maintenance practices at the moment. So it's creating this virtual twin of the real world, and you can see where you can make decisions in the virtual world, and then see how they're applied across to the real world, the physical world. So it's quite exciting. So there's been a lot of work in kind of the automotive industry and the electronics industry on this topic currently, and a lot of those lessons are being moved across into the maritime industry. I think we're going to see more of this digital twin technology being added into the maritime sector, but I think we're going to see it expand as well. So it's become its own ecosystem. So you're going to see maybe entire fleets and supply chains and port interfaces are going to be added into this kind of whole ecosystem, which is going to involve digital twins. And of course, there's going to be opportunities for sustainability and the way that sustainability is practiced within this kind of ecosystem as well. I think it's one to watch for. I think we get a lot of lessons from other industrial sectors about what might be coming down the tracks, but the adaptation across to the maritime sector is going to be interesting to see.
Perfect. Thanks, Paul. Marie?
Yeah, I would agree with Paul. I think it's going to be a big shift in how sustainability is practiced. And in that regard, I think one transformative idea would be to really embed that concept of ocean literacy within curriculum, within operation, within training. I think for me, that's going to be like the big shift in the next 10 years. And the IMO is very much on topic with that. And that can be done by integrating interactive learning, field experiences, industry partnership, ongoing CPD and awareness programs. So then that will allow marine engineers to become not only very strongly and amazingly skilled technicians, but also passionate ocean stewards. And I think for me, that ocean literacy concept allows marine engineers and everyone who's working on the ocean and living on the ocean to become custodian and to really reinforce that sense of responsibility, which is so important nowadays.
Thanks, Marie. Thanks, Paul. So to wrap up this fantastic webinar, we have just 2 minutes left. I would like to ask you one final question. We have many students who are participating in this webinar and probably much more who are going to follow in the webinar library of the IMarEST. So how can we inspire the next generation, the students, to pursue a future in this incredible industry that is the maritime one?
I'm happy to start on that one, Paul, if that's okay. Sure. Well, I think here I'd like to refer to the fantastic program that my colleague Elina Primilko is running at MLA College, which is about sustainable maritime operations. And she's doing a fantastic job in making it incredibly progressive. So I think students can really become part of the change by learning how to implement the change, learning about sustainability and that more holistic approach. And equally, what Paul is doing with the engineering degrees and embedding and weaving sustainability in there is going to support students' inspiration, vision to, again, become drivers for change and take ownership in shaping the world we are living in.
For me, I mean, I agree with all what Mary said. You know what I mean? I think they're self-evident lessons that we're learning here. I think it's so important that we acknowledge the vast level of expertise that engineers have currently. Sometimes I think the poor old engineers feel that their skill set is somehow being challenged a little bit by these new things that we talk about with sustainability, which is a shame because there's so much to offer. I think it's sometimes just top ups or adding a little bit more knowledge on new areas that they mightn't be familiar with. So encouraging them in any way to kind of to come into topics such as examining sustainability is going to be really, really important. Uh, Encouraging them to look at not just the maritime sector, but all sectors, the systems thinking that's involved there, breaking down those barriers between, shall we say, engineers and non-engineering personnel, and integrating more and more people. I think we're going to see more and more people that mightn't come from an engineering background going into kind of engineering roles in the future. Similarly, I think we're going to see more and more engineering people that always thought they were going to remain as engineers to suddenly find that they're outside of their, shall we say, the comfort zone of their background, where they started off, and they're increasingly picking up new skills, very, very valuable skills from colleagues in all sorts of disciplines that they wouldn't normally think that they would be working with. And I think it's our job as educators, myself and Mary, to kind of encourage that and continue to encourage that. And I think we're going to see more and more of that. And so the courses that we hope to produce will hopefully allow us to do this more, or that we're inventive enough to kind of come up with ways to allow this kind of perspective to flourish.
Okay, I think that there is not better wrap up than the one that you have done. So I would like to thank you, Marie, Paul, for your insightful comments. And I would like to thank also the MLA College and the IMarEST for organizing this webinar. And I would like to thank a lot to the attendees on live or the people who are going to listen this webinar in any other moment. So thank you very much, everyone, and see you in the next webinar. Bye bye.
Thank you.
Thank you,
Bye bye.
everyone. Bye. Thank you, Rodrigo.